So in this video, we'll look at how to find the arc length of a curve if it is presented as a parametric curve. And let's come back to the arc length element. So we can call the arc length element to be something like that. And there's a reason behind that, because when you look at the curve, when you look at a very small part, like we call this part like the very small difference of the x coordinates of the 2 points, and this part is the very small difference of the y coordinates of 2 points. If you take a look at this one, approximately speaking, is kind of like a right angle triangle. If you look at this length, because approximately speaking, it is very close to a right angle triangle. So approximately speaking, the length just for this part by the Pythagoras theorem is going to be the square root of the small difference of x square plus the difference of y square, right? And that's how we get this arc length element for a general curve. And let's look at our current case of parametric curve. You should be given y as a function of t and x as a function of t. And because of the area element here, it essentially means we have something like that is for the dx, the whole thing square, plus the dy for the whole thing square, right? And which means we have something like that. And please note that this one, for example, like dg is essentially the derivative of g, and we can write the dt after that. So it means that for the arc length element, we can present it actually by g prime the whole thing square plus f prime the whole thing square, and we can push the dt out. I hope you see what I'm doing. I can actually add a step here, because in this case we are getting something like g prime dt inside the whole thing square plus open bracket f prime dt the whole thing square, and we can pull out the dt square out of the square root, so we get dt. And that's basically the arc length element for our current case of the parametric curve. So it means that essentially speaking, we get the arc length formula, which is from certain starting point t naught to an end point. This one is a start point, this one is the end point. We have to integrate this arc length element from the starting point of certain curve and to the end point of this curve. And let's look at an example here. So please look at the given parametric curve now. If I'm asking for the arc length along the curve from the starting point t equals 0 to the ending point t equals 1, can you tell me the formula of the arc length? So I can write it based on the formula given at the top here. And you have to integrate the variable t from 0 to 1, and the content inside the integral is square root of something. So please think about this. What is the g prime? The g prime is the derivative of this function, which is 6t squared, right? Plus something squared, and this something is gonna be the f prime. The f prime is the derivative of 3t squared plus 1, which is 6t, right? And I trust that you're able to do these computations, but I write down the remaining steps. So you see, after some simplifications, you're asked to integrate this function 6t times square root of t squared plus 1. And actually, I think we can use the u substitution. I can let u be t squared plus 1, and the u is actually 2t times dt. So to save up a bit of time, I will remaining steps down. So please look at the purple box on the bottom right-hand corner. If you use the u substitution successfully, you should be getting antiderivative like this at the end. So at the end, that's basically the final answer to the arc length of this curve from t equals 0 to t equals 1. And that's the end to this video.